Hi learners! In this video lesson, we will be talking about rocks in the rock cycle. So if you are ready, let's begin. Rocks are everywhere. Mountains, valleys, and the seafloor are made of rocks. Rock and mineral resources even make up parts of your home. Today, it is common for floors, countertops, and even tabletops to be made of some type of rock. A rock is a natural, solid mixture of minerals or grains. Individual mineral crystals, broken bits of minerals, or rock fragments make up these grains. Sometimes a rock contains the main of an organism or volcanic glass. Geologists call the fragments that make up a rock grains. They use a grain size, shape, and chemical composition to classify rocks. Geologists use two important observations to classify rocks: texture and composition. The grain size and the way grains fit together in a rock are called texture. When a geologist classifies a rock by its texture, he or she looks at the size of the minerals or grains in the rock, the arrangement of these individual grains, and the overall feel of the rock. Texture also can be used to determine the environment in which a rock are formed. For example, the granite that shown in the picture. It has a large minerals. These colorful, crystalline texture help geologists classify this rock as an igneous rock. For example, the conglomerate. Conglomerate has rounded rock fragments. Well-rounded rock fragments imply that strong forces such as water or ice curved an individual classed and produced smooth surfaces. This is sedimentary rock. You will learn more about igneous, sedimentary, and the third rock type, metamorphic rock, in these video lessons. Another way that geologists classify rocks are based on their composition. The minerals or grains present in a rock help geologists classify the rock's formation. This information can be used to determine where the rock formed, such as inside a volcano or alongside a river. Geologists conduct field work using maps, a field journal, a compass, a rock hammer, and other tools to examine rock composition and texture. For example, the presence of certain minerals might suggest that the rock formed under extreme temperature and pressure. Other minerals indicate that the rock formed from molten material deep beneath Earth's surface. Geologists classify rocks or place them in two groups based on how they formed. The three major groups of rocks are igneous, sedimentary, and metamorphic rocks. Geologists can interpret the environment where these rocks form based on the physical and chemical characteristics of each type of rock. First, let's talk about sedimentary rocks. When rocks are exposed on Earth's surface, they can break down and be transported to new environments. Forces such as wind, running water, ice, and even gravity cause rocks on Earth's surface to break down. Sediment is rock material that forms where rocks are broken down into smaller pieces or dissolved in water as rocks erode. These materials, which include rock fragments, mineral crystals, or the remains of certain plants and animals, are the building blocks of sedimentary rocks. Sedimentary rocks form where sediment is deposited. Sedimentary environment include rivers and streams, deserts, and valleys. Sedimentary rocks can be found in mountain valleys, along river banks, on the beach, or even in your backyard. How a sedimentary rock formed? Like igneous rocks, sedimentary rocks can form in different environments through a series of natural steps. Water and air can change the physical or chemical properties of rock. These changes can cause the rock to break apart, to dissolve, or to form new minerals. When water travels through rock, some of the elements in the rock can dissolve and be transported to new locations. Mineral and rock fragments can also be transported by water, glacial ice, gravity, or wind. The sediments eventually are deposited or laid down where they can then accumulate in layers. Imagine sediment deposits becoming thicker over time. Younger sediment layers bury older sediment layers. Then eventually, the old and young layers of sediments can be buried even younger sediment deposits. The weight from the layers of sediment forces out fluids and decreases the space between grains during the process. This is called compaction. Compaction can lead to a process called cementation. When minerals dissolve in water, crystallize between sediment grains, this process is called cementation. Mineral cements holds the grains together. Common minerals that cement sediment together include quartz, calcite, and clay. Like igneous rocks, sedimentary rocks are classified according to how they are formed. Sedimentary rocks form when sediments, rock fragments, minerals, or organic materials are deposited, compacted, and then cemented together. They also form during evaporation when minerals crystallize from water or when organisms remove minerals from the water to make their shells or skeletons. There are three types of sedimentary rocks: clastic, chemical, biochemical. Clastic sedimentary rocks are large sediment pieces where polished and rounded and deposited. Clastic sedimentary rocks are formed through weathering, erosion, deposition, compaction, and cementation. One of the characteristics of clastic sedimentary rocks is that they have gritty texture and some are layered. They are made up of broken pieces of minerals and rock fragments. They are also formed near river channel, seafloor, or at the bottom of a lake. Geologists identify clastic rocks according to class size and shape. The conglomerate, for example, that was deposited in a river channel. The large sediment pieces were polished and rounded as they bounced along the bottom of the channel. However, the angular fragments in the breccia probably weren't transported far because their sharp edges were not worn away. Sediment size alone cannot be used to determine environment where a clastic rock formed. For example, sediment deposited by a glacier can be size of a car or as small as grains of flour. That's because ice can be both large and small classed. Geologists study the shape of glass to help determine the environment where a rock formed. For example, a fast-flowing river and ocean waves tend to move large sediment. Small, gritty sediment is typically deposited in calm environments such as the seafloor or at the bottom of a lake. The clasts in the conglomerate on the left were rounded by a fast-flowing river. The forces that created the angular fragments of breccia may not have been as strong or as long-lived. A chemical sedimentary rock is formed when minerals crystallize directly from water. They have interlocking crystalline texture similar to igneous. They made up of one dominant mineral and uniform in color. They are also formed near ocean or cave. Remember that as the water flows through cracks or empty spaces in rock, it can dissolve minerals in the rock. Eventually, rivers carry these dissolved minerals to the oceans. Dissolved minerals entering the ocean contribute to the saltiness of seawater. Water can become saturated with dissolved minerals. When this occurs, particles can crystallize out of the water and form minerals. This is how rock gypsum and rock salt were formed. Biochemical rock is a sedimentary rock that was formed by organisms or contains the remains of organisms. They are formed when remains settles on the ocean floor and it will be compacted and cemented together. They have gritty texture and they are mostly formed in the ocean. Limestone is classified as a type of carbonate rock because it contains the elements carbon and oxygen. Carbonate rocks will fizz when they come into contact with hydrochloric acid. Geologists use this chemical property to help identify different varieties of limestone. Not all biochemical sedimentary rocks are carbonates. Some microscopic ocean organisms make their shells by removing silicon and oxygen from seawater. When these organisms die and settle on the ocean floor, compaction and cementation turns this sediment into the sedimentary rock chert. Coal is another type of biochemical sedimentary rock. It is composed of the remains of plants and animals. Over time, these organic remains were buried. Burial led to compression, which eventually changed the remains into a sedimentary rock. Another type of a rock is an igneous rock. You might remember that when magma, molten or liquid rock underground cools, mineral crystals form. Molten rock that erupts on Earth's surface is called lava. When magma or lava cools and crystallizes, it creates igneous rock. As mineral crystals grow, they connect much like pieces of jigsaw puzzle. These crystals become the grains in an igneous rock. The texture and composition of these grains help geologists to classify the type of igneous rock and the environment where this rock may have formed. Igneous rocks form in a variety of environments, including subduction zones, mid-ocean ridges, and hotspots where volcanoes are common. There are two types of igneous rocks. Igneous rocks that form as magma cools underground are called intrusive rocks. Because magma within Earth is insulated by solid rocks, it cools more slowly than lava on Earth's surface. When magma cools slowly, large, well-defined crystals form. Like on the picture, a cross-section of Earth crust where a magma chamber has solidified and formed intrusive rock. The arrangement of crystals in intrusive rocks is random. Crystals interlock like jigsaw puzzle pieces. A random arrangement and the large crystals are typically of intrusive igneous rocks. An example of an intrusive rock is the granite. On the other hand, when volcanic materials erupts and cools and crystallizes on Earth's surface, it forms a type of igneous rock called extrusive rock. Materials such as lava and ash solidify and form extrusive igneous rocks. Lava can cool rapidly on Earth's surface. This means that there might not be enough time for any crystals to grow. Extrusive igneous rocks therefore have fine-grained texture. Volcanic glass is rock that forms when lava cools too quickly to form crystals, such as the obsidian. Magma stored underground can contain dissolved gases. As magma moves toward the surface, pressure decreases, and the gases separate from the molten mixture. This is similar to the carbon dioxide that escapes when you open a carbonated beverage. When gas-rich lava erupts from a volcano, gases escape. Among the most noticeable feature of some extrusive igneous rocks such as pumice are holes that are left after gas escapes. Here are some examples of igneous rocks. For intrusive, diorite, granite, pegmatite, gabbro. For extrusive, basalt, andesite, rhyolite, and scoria. Another type of a rock is a metamorphic rocks. Metamorphic rocks form from pre-existing rocks that react to changes in temperature and pressure or the addition of chemical fluids. Metamorphism is any process that affects the structure or composition of a rock in a solid as a result of changes in temperature, pressure, or the addition of chemical fluids. When rocks are exposed to an extreme temperature and pressure, such as along plate boundaries, they can change to metamorphic rocks. The addition of chemical fluids can also cause the rocks to become metamorphic rocks. The minerals that make up the rock's composition change as well as the texture or arrangement of the individual mineral grains. In many cases, the change is so intense that the arrangement of the grains appears as bent or twisted layers. Metamorphic rocks can form from any igneous or sedimentary rocks, or even another metamorphic rocks. For example, the igneous rock granite metamorphoses into gneiss, and the sedimentary rock limestone metamorphoses into marble. When rocks experience an increase in temperature and pressure, they behave like a bendable plastic. Without melting, the rocks bend or fold. This permanent change in shape by bending and folding is called plastic deformation. It's one way the texture of a rock changes during metamorphism. Plastic deformation occurs during uplift events when tectonic plates collide and form mountains such as the Himalayas in Asia. Changes in composition and structure are clues that a rock has been metamorphosed. There are two types of metamorphic rocks. First is the foliated rocks. Foliated rocks contain parallel layers of flat and elongated minerals. Look closely at the picture. This layering results from an uneven distribution of pressure during metamorphism. Foliation is a common feature in metamorphic rocks. Elongated or flat minerals in foliated rocks lined up in a response to pressure. Non-foliated rock is a type of metamorphic rocks that have mineral grains with a random interlocking texture. There is no obvious alignment of the mineral crystals in a non-foliated metamorphic rock. Instead, the individual crystals are blocky and approximately equal in size. This crystalline texture differs from an igneous rock in that the minerals are generally uniform in colors as opposed to multicolored as an igneous rock such as granite. Here are the examples of metamorphic rocks. For foliated rocks, as the metamorphism increases, slate becomes phyllite, phyllite becomes schist, and schist becomes gneiss. Gneiss is the extent of a metamorphic rock. For non-foliated, a pre-existing rock called limestone turns into marble. Sandstone becomes quartzite. Shale becomes hornfels. There are two ways of metamorphism. One way a non-foliated metamorphic rock can form is when magma intrudes rock. During contact metamorphism, magma comes into contact with existing rock and its thermal energy and gases interact with the surrounding rock, forming a new metamorphic rock. Contact metamorphism can increase crystal size or form new minerals and change rock. A common example of non-foliated rocks are marble. Marble are from limestone. Quartzite is from sandstone. And hornfels are from shale. On the other hand, regional metamorphism is the formation of metamorphic rock bodies that are hundreds of square kilometers in size. These processes can create an entire mountain range of metamorphic rock. Changes in temperature and pressure and the presence of chemical fluids act on the large volumes of rocks and produce metamorphic textures. These textures can help unravel the mysteries of mountain building event. The Himalayas in Asia and the Appalachian Mountains of the eastern United States exhibited structures associated with regional metamorphism. To wrap up the lesson, the three types of rocks are sedimentary, igneous, and metamorphic rocks. In our next video lesson, we will be learning about rock cycle. So stay tuned!